Hi, it's Carly McAvoy. I'm talking about the Math 90 Basic Math final exam review. We're looking at decimals and ratios and rates and proportions in this video. Start with decimals. When you're multiplying with decimals, you multiply just like you normally would. So I'm going to multiply 2 times 3 and 3 times 7. 15 and 2 is 17 is 6. Add a 0. 1 times 2 is 2. 1 times 7 is 7. 1 times 5 is 5. 1 times 2 is 2. And then I'm not going to bother to put the 0 in there, but what I'm going to do is add this up. 6, 3, 14, 11, 12. And then I have to decide, where does the decimal point go. So look at the factors. I have 1, 2, 3, 4, 5 decimal places in my factors. So in my product, or my answer, I also need 5. So I need 1, 2, 3, 4, 5. That means the decimal point has to go in the front there to give me 5 decimal places, which is the combined total of the decimal places in my problem. Over here, I would add these two things together first. If you're not sure, you can add them up on your calculator. I have no problem with calculators for the final, when you've already practiced the stuff, plus 2.07, and that gives you 2.6. So I would like to see what process you're going through to solve this. So show me the top, and then the next thing you're going to do is divide by 4. 2.6 divided by 4. Well, 4 doesn't go into 2. Bring the decimal point straight up. 4 goes into 26 6 times. 6 times 4 is 24. Then you bring down, so get 2, add another 0, add that down at the bottom, and then 4 goes into 25 times. So I get 0.65 for my answer. Whoops, my decimal answer. Add the top and then divide by 4. I just want to remind you that if I'm saying subtract from something, you need to put this something first. So I'm subtracting 6.23 from 11.4. I need to line up those decimal places, remember? It doesn't matter about lining up decimal places when you multiply, but it does matter when you're add and subtract. And so what I want to do here is add a 0 so that I can then have something to subtract. I'm going to borrow from this, and then 10 minus 3 is 7. 3 minus 2 is 1. I'll borrow here, make that 11. 11 minus 6 is 5. And my decimal point comes straight down into the answer. How do you check that? Well, you just add up the subtrahend and the difference here, and you should get what you started with, which is the minuend. Okay. When you want to write a ratio has the same units. So I left this off, but in the computer they had an example where you're talking about bytes to bytes. Whatever you say first has to go on the top, and whatever you say second has to go on the bottom. And then you always want to reduce that to lowest terms, 54,000 to 36,000. Well, I know for sure that all those zeros could just cancel out, so I'm really only reducing 54 to 36. So I'm going to do that on my calculator, but of course you could say, well, I'm going to divide the top and the bottom by 6 and see what I get. Or you could do a lot of different things here. So I'm going to do 54 over 36, and that gives me 3 over 2. So I could have divided by 18. That would have been a straight, direct way to go there. You can decide what you would have been dividing by. But anyway, that was 3 over 2. When you want to write a ratio, you don't ever change it to a mixed number. You just leave it like that. 3 bytes to 2 bytes is 3 to 2. On the other hand, a rate, well, the rate is something that has 2 different units, like a driver compared to a car. But again, what you say first goes on top. So you have 268 compared to 4. In a rate, you want to get it down to having a 1 in the bottom, so you actually want to do this multiplication. So you're going to take 264, or division, sorry, 268. Geez, where am I getting 4? And divide, and you get 67. So the rate is 67 drivers per 1 car. We always want a rate to have a 1 on the bottom. So for every car, there's 67 drivers. That's different because here, rate has two different units that we're talking about. A ratio is the same. It has to be the same for us to find that ratio. All right, let's look at the next page. If a car is going, I guess that should be how many? I miswrote that earlier. A car going 60 miles per hour is moving how many miles per second? So I want to change that and change it into from miles per hour into miles per second. And there's a little bit more of this coming up on the next video. But anyway, so I have 60. This is a rate because we have miles per hour. Those are two different units, right? But what I want to do is multiply this by something so that instead of having hours on the bottom, I have seconds on the bottom. So what I want to do is put hours up here so that the hours cancel each other. But what is the conversion between hours and seconds? Well, there's 60 minutes in 1 hour and there's 60 seconds in 1 minute. So in order to get what the conversion is here, we have to take 60 times 60, or 3,600 seconds in 1 hour, because there's 60 minutes, but 60 of those. I kind of got off the screen there. So I have 3,600 seconds for 1 hour. So you can see that the hours cancel. I've got miles on top and seconds on the bottom, which I want. And then I have to do 60 divided by 3,600. And that's 0.016. I'm going to round that to 0.017 miles per second. All right, so it doesn't tell us as much as 60 miles per hour. We're used to that. All right, three more. What's the better buy? 48 ounces of Golden Crunchies for $5.90, or 30 ounces of Golden Crunchies for $3.72. So what you're looking for here is a rate, and you're looking for cost per ounce. So we're going to take the first one. We're going to take the cost of $5.90 and per ounce, which there's 48 ounces. And for the second one, we're going to take the cost of $3.72 for 30 ounces. And now I'm going to go ahead and divide that. 5.9 divided by 48 gives me 0.12. I'm going to round it to the third place. Don't ever round to the second. It's hard to tell. So we're going to round to the third, 0.13. Sometimes you have to go out 3 places to see the difference. Then I'm going to take 3.72 and divide by 30. And that gives me 0.124. So these are different by the thousandths place, the thousandths of a cent more if you buy the 30 ounce, because this was the 30 ounce. So the better buy is actually the first one, but not by much. So in this case, buy the one you want, because it doesn't really change that much. If you have to solve a proportion, then you want to cross multiply. Remember, we have these. If you go from one side to the other like this, these are called the means. And this way we have the extremes. And so I have 11x equals 33 times 4, 132. My brain is kind of slow right now. And then once you cross multiply to get that, 4 times 33, 11 times x, you divide by this number. This number is called the coefficient. That's a term that's going to come up in algebra, so you want to make sure you're getting familiar with it. If I divide 11 by itself, they just go away, right? That's what I want to happen. So over here, if I take 132 and divide by 11, I get 12. So that's how I solve that. X is 12 there. Notice how I state the answer. X equals 12. I don't go back and do 4 is 11 as 12 is 33 and then hope for the person to find my answer in that. My answer is this, even though this is true, but the answer should be stated as x equals some number. And the last one, 5 out of every 14 M&Ms are red. How many red M&Ms are in, I didn't write these problems very carefully, 562 M&Ms. Round to the nearest whole number. So we have red compared to the total. So when there's 14 total, we would expect 5 red. So the question is, how many red would we have if we had 562 in total? And this is solving a proportion just like we did up above. I can pull that down so you can see. We're going to cross multiply. So we're going to take 14 times R, and then we're going to take 5 times 562. You don't have to write those arrows. I just do to see what's happening. You can see what's happening. 5 times 562 is 2,810. And then what's the coefficient in this problem? The coefficient is always this number that's multiplying the variable. So we're going to divide both sides by 14. And it told us to round to the nearest whole number, but 2,810 divided by 14 is 200.71. And so now if I want to round that to the hundreds, then we would expect, and for red, the little approximately means we're going to have approximately 201 red M&Ms if we had 562 total, because the 7 is more than 5, so we round that 0 up to 1 to get to the nearest whole number. All right, have a fantastic day, and then watch the B part of this coming up soon.